Scaffolding, also called scaffold staging, is a temporary structure used to support a work crew in materials to aid in the construction, maintenance and repair of buildings, bridges and all other man-made structures. Scaffolding is also used in adapted forms for formwork, ensuring grandstand seating, concert stages, access viewing towers, exhibition stands, ski ramps, half-pipes and art projects. There are four main types of scaffolding used worldwide today. These are tube and coupler components, prefabricated modular system scaffold components, H-frame, facade modular system scaffolds, and timber scaffolds. Each type is made from several components which often include a base jack, a plate which is a load-bearing base for the scaffold, the standard which is the upright component with connector joins, the ledger, the transom which is a horizontal cross-section load-bearing component which holds the batten, border decking unit, brace diagonal and, or cross-section bracing component, batten, a board decking component used to make the working platform, coupler, a fitting used to join components together, scaffold tie used to tie in the scaffold to structures, brackets used to extend the width of working platforms, specialized components used to aid in the use as a temporary structure often include heavy-duty load-bearing transoms, ladders or stairway units for the ingress and egress of the scaffold, beams, ladder unit types used to span obstacles, and rubbish chutes used to remove unwanted materials from the scaffold or construction project. History. Antiquity. Sockets in the walls around the Paleolithic cave paintings at Lasso suggest that a scaffold system was used for painting the ceiling, over 17,000 years ago. The Berlin Foundry Cup depicts scaffolding in ancient Greece. Egyptians, Nubians and Chinese are also recorded as having used scaffolding-like structures to build tall buildings. Early scaffolding was made of wooden secured with rope knots. Modern era. In days gone by, scaffolding was erected by individual firms with wildly varying standards and sizes. Scaffolding was revolutionized by Daniel Palmer Jones and David Henry Jones. Modern-day scaffolding standards, practices and processes can be attributed to these men and the companies, with Daniel being the better-known and patent applicant and holder for many scaffold components still in use today. See inventor, Daniel Palmer Jones. He is considered the grandfather of scaffolding, the history of scaffolding being that of the Jones brothers and the company's patent Rapid Scaffold Tie Company Limited, Tubular Scaffolding Company and Scaffolding Great Britain Limited. David Palmer Jones patented the Scaffixer, a coupling device far more robust than rope which revolutionized scaffolding construction. In 1913, his company was commissioned for the reconstruction of Buckingham Palace, during which his Scaffixer gained much publicity. Palmer Jones followed this up with the improved universal coupler in 1919. This soon became the industry standard coupling and has remained so to this day, or as Daniel would say, be it known that on Daniel Palmer Jones, manufacturer, subject to the King of England, residing at 124 Victoria Street, Westminster, London, England, have invented certain new and useful improvements in devices for gripping, fastening, or locking purposes, segment from a patent application. With the advancements in metallurgy throughout the early 20th century, saw the introduction of tubular steel water pipes with standardized dimensions, allowing for the industrial interchangeability of parts and improving the structural stability of the scaffold. The use of diagonal bracings also helped to improve stability, especially on tall buildings. The first frame system was brought to market by SGB in 1944 and was used extensively for the post-war reconstruction. Scaffolding today. The European standard, BSN 12811-1, specifies performance requirements and methods of structural and general design for access and working scaffolds. Requirements given are for scaffold structures that rely on the adjacent structures for stability. In general, these requirements also apply to other types of working scaffolds. The purpose of a working scaffold is to provide a safe working platform and access suitable for workers to carry out the work. The European standard sets out performance requirements for working scaffolds. These are substantially independent of the materials of which the scaffold is made. The standard is intended to be used as the basis for inquiry and design. Materials. The basic components of scaffolding are tubes, couplers and boards. The basic lightweight tube scaffolding that became the standard and revolutionized scaffolding, becoming the baseline for decades, was invented and marketed in the mid-1950s. With one basic 24-pound unit of scaffold of various sizes and heights could be assembled easily by a couple of laborers without the nuts or bolts previously needed. Tubes are usually made either of steel or aluminium, although there is composite scaffolding, which uses filament wound tubes of glass fiber in a nylon or polyester matrix. Because of the high cost of composite tube, it is usually only used when there is a risk from overhead electric cables that cannot be isolated. If steel, they are either black or galvanized. The tubes come in a variety of lengths and a standard diameter of 48.3 mm. The chief difference between the two types of metal tubes is the lower weight of aluminium tubes. However, they are more flexible and have a lower resistance to stress. Tubes are generally bought in 6.3 meters lengths and can then be cut down to certain typical sizes. Most large companies will brand their tubes with the name and address in order to deter theft. Boards provide a working surface for scaffold users. They are seasoned wood and come in three thicknesses: 50 mm and 63 mm are a standard width and are a maximum of 3.9 meters long. The board ends are protected either by metal plates called hoop irons or sometimes nail plates, which often have the company name stamped into them. Timber scaffold boards in the UK should comply with the requirements of BS 2482. As well as timber, steel or aluminium decking is used, as well as laminate boards. In addition to the boards for the working platform, there are sole boards which are placed beneath the scaffolding if the surface is soft or otherwise suspect, although ordinary boards can also be used. Another solution, called a scaff pad, is made from a rubber base with a base plate molded inside. These are desirable for use on uneven ground since they adapt, whereas sole boards may split and have to be replaced. Couplers of the fittings which hold the tubes together. The most common are called scaffold couplers, and there are three basic types: right-angle couplers, put-hole couplers and swivel couplers. To join tubes end-to-end, joint pins or sleeve couplers are used. Only right-angle couplers and swivel couplers can be used to fix tube in their load-bearing connection. Single couplers are not load-bearing couplers and have no design capacity. Other common scaffolding components include base plates, ladders, ropes, anchor ties, reveal ties, gin wheels, sheeting, etc. Most companies will adopt a specific color to paint the scaffolding with in order that quick visual identification can be made in case of theft. All components that are made from metal can be painted, but items that are wooden should never be painted, as this could hide defects. Despite the metric measurements given, many scaffolders measure tubes and boards boards in imperial units, with tubes from 21 feet down and boards from 13 feet down. Bamboo scaffolding is widely used in Hong Kong, with nylon straps tied into knots as cupolas. In India, bamboo or other wooden scaffolding is also mostly used, with poles being lashed together using ropes made from coconut hair. Basic scaffolding. The key elements of the scaffolding are the standard, ledger and transoms. The standards, also called uprights, are the vertical tubes that transfer the entire mass of the structure to the ground, where they rest on a square base plate to spread the load. The base plate has a shank in its center to hold the tube and is sometimes pinned to a sole board. Ledges are horizontal tubes which connect between the standards. Transoms rest upon the ledges at right angles. Main transoms are placed next to the standards. They hold the standards in place and provide support for boards. Intermediate transoms are those placed between the main transoms to provide extra support for boards. In Canada, this style is referred to as English. American has the transoms attached to the standards and is used less but has certain advantages in some situations. Since scaffolding is a physical structure, it is possible to go in and come out of scaffolding, as well as the tubes at right angles that are across braces to increase rigidity. These are placed diagonally from ledger to ledger, next to the standards to which they are fitted. If the braces are fitted to the ledges, they are called ledger braces. To limit sway, a facade brace is fitted to the face of the scaffold every 30 meters or so at an angle of 35 degrees to 55 degrees, running right from the base to the top of the scaffold and fixed at every level of the couplers previously mentioned. Right-angle couplers join ledges at transoms to standards. Put-auger single couplers join board-bearing transoms to ledges. Non-board-bearing transoms should be fixed using a right-angle coupler. Swivel couplers are to connect tubes at any other angle. The actual joints are staggered to avoid occurring at the same level in neighboring standards. The spacings of the basic elements in the scaffold are fairly standard. For a general-purpose scaffold, the maximum bay length is 2.1 meters. For heavier work, the bay size is reduced to 2 or even 1.8 meters, while for inspection a bay width of up to 2.7 meters is allowed. The scaffolding width is determined by the width of the boards. The minimum width allowed is 600 mm, but a more typical 4-board scaffold would be 870 mm wide from standard to standard. More heavy-duty scaffolding can require 5, 6, or even up to 8 boards width. Often an inside board is added to reduce the gap between the inner standard and the structure. The lift height, the spacing between ledges, is 2 meters, although the base lift can be up to 2.7 meters. The diagram above also shows a kicker lift, which is just 150 millimeters or so above the ground. Transom spacing is determined by the thickness of the boards supported. 38 mm boards require a transom spacing of no more than 1.2 meters, while a 50 mm board can stand a transom spacing of 2.6 meters, and 63 mm boards can have a maximum span of 3.25 meters. The minimum overhang for all boards is 50 mm and the maximum overhang is no more than 4x the thickness of the board. Foundations. Good foundations are essential. Often scaffold frameworks will require more than simple base plates to safely carry and spread the load. Scaffolding can be used without base plates on concrete of similar hard surfaces, although base plates are always recommended. For surfaces like pavements or tarmac, base plates are necessary. For softer or more doubtful surfaces, sole boards must be used. Beneath a single standard, a sole board should be at least 1,000 square centimeters with no dimension less than 220 millimeters. The thickness must be at least 35 millimeters. For heavier-duty scaffold, much more substantial balks set in concrete can be required. On uneven ground, steps must be cut for the base plates. A minimum step size of around 450 mm is recommended. A working platform requires certain other elements to be safe. They must be close-boarded, have double guardrails and toe and stop boards. Safe and secure access must also be provided. Ties scaffolds are only really independent structures. To provide stability for a scaffolding framework, ties are generally fixed to the adjacent building, fabric, steelwork. General practice is to attach a tie every 4 meters on alternate lifts. Prefabricated system scaffolds require structural connections at all frames, i.e., 2 to 3 meters centers. The ties are coupled to the scaffold as close to the junction of standard and ledger as possible. Due to recent regulation changes, scaffolding ties must support plus or minus loads and lateral loads. Due to the different nature of structures, there is a variety of different ties to take advantage of the opportunities. Through ties are put through structure openings such as windows. A vertical inside tube crossing the opening is attached to the scaffold by a transom, and a crossing horizontal tube on the outside called the bridle tube. The gaps between the tubes and the structure surfaces are packed or wedged with timber sections to ensure a solid fit. Box ties are used to attach the scaffold to suitable pillars at comparable features. 2 additional transoms are put across from the lift on each side of the feature and are joined on both sides with shorter tubes called tie tubes. When a complete box tie is impossible, a L-shaped lip die can be used to hook the scaffold to the structure. To limit inward movement, an additional transom, a butt transom, is placed hard against the outside face of the structure. Sometimes it is possible to use anchor ties. These are ties fitted into holes drilled in the structure. A common type is a ring bolt with an expanding wedge which is then tied to a node point. The least invasive tie is a reveal tie. These use an opening in the structure but use a tube wedged horizontally in the opening. The reveal tube is usually held in place by a reveal screw pin and protective packing at either end. A transom tie tube links the reveal tube to the scaffold. Reveal ties are not well regarded. They rely solely on friction and need regular checking, so it is not recommended that more than half of all ties be reveal ties. If it is not possible to use a safe number of ties, rakers can be used. These are single tubes attached to a ledger extending out from the scaffold at an angle of less than 75 degrees and securely founded. A transom at the base then completes a triangle back to the base of the main scaffold. Specialty scaffolding. Types of scaffolding covered by the Occupational Health and Safety Administration in the United States include the following categories: pole, tube and cupola, fabricated frame, plasterers, decorators, and large area scaffolds, bricklayers, horse, form scaffolds and carpenters, bracket scaffolds, roof brackets, outrigger, pump jacks, ladder jacks, window jacks, crawling boards, step, platform, and trestle ladder scaffolds, single-point adjustable suspension, two-point adjustable suspension, multi-point adjustable suspension, stone setters, multi-point adjustable suspension scaffolds, and masons multi-point adjustable suspension scaffolds, catenary, float, interior hung, needle beam, multi-level suspended, mobile, repair bracket, scaffolds, and stilts. Gallery of scaffold types. Putlog scaffold. In addition to the putlog couplers, there are also putlog tubes. These have a flattened end and have been fitted with a blade. This feature allows the end of the tube to be inserted into a rest upon the brickwork of the structure. A putlog scaffold may also be called a bricklayer's scaffold. As such, the scaffold consists only of a single row of standards with a single ledger. The putlogs are transoms, attached to the ledger at one end but integrated into the bricks at the other. Spacing is the same on a putlog scaffold as on a general-purpose scaffold, and ties are still required. In recent years, a number of new innovations have meant an increased scope of use for scaffolding, such as ladder beams for spanning spaces that cannot accommodate standards and the increased use of sheeting and structure to create temporary roofs. Pump jack. A pump jack is a type of portable scaffolding system. The scaffold rests on supports attached to two or more vertical posts. The user raises the scaffolding by pumping the foot pedals on the supports, like an automobile jack. Baker staging. Baker staging is a metal scaffold which is easy to assemble. Rolling platforms, typically 740 mm wide by 1.8 meters long and 1.8 meters tall sections which can be stacked up to 3 high with the use of added outriggers. The work platform height is adjustable. X-deck ladder scaffolding. Low-level scaffolding that is height adjustable. It is a hybrid ladder scaffold work platform. Standards. The widespread use of scaffolding systems, along with the profound importance that they earned in modern applications such as civil engineering projects and temporary structures, led to the definition of a series of standards covering a vast number of specific issues involving scaffolding. Among the standards there are DIN 4420, a DIN standard divided in 5 parts which covers the design and detail of scaffolds, ladder scaffolds, safety requirements and standard types, materials, components, dimensions and load-bearing capacity. DIN 4421, a DIN standard which covers the analysis, design and construction of falsework. 29 CFR Part 1926, safety standards for scaffolds used in the construction industry from the U.S. Occupational Safety and Health Administration, with an accompanying construction tool.